Okay, I'm Dr. Codd, Director of Mechatechs. This is STEM Sunday for us here and you all who are following us on YouTube. So today is a week before the first eclipse, what they call the double header eclipse that we're going to have. Next Saturday is the first one, and then April of next year is the second one, which is a totality eclipse. This one is an annular, so we're going to use it as a practice session to get ready for the one in April. So basically this is the first session on astronomy and what you need to start locating yourself. Now we're using telescopes at what they call EAA, Enabled Assistance Astronomy. And that means the telescope will do a lot of the work for you that you had to do before. Now we have the robotic scopes that actually add on top of that and will do a lot more. So we've got 2 or 3 new generations of telescopes to do astronomy over what we did before, but you still have to know the basic sky. The basic sky is divided into 3 parts, okay? So, and the first part of it is looking at the sky with your naked eye. So they call it naked eye astronomy. The second part is when you start to use some kind of assist, which is basically is usually optics. So that's a binocular, telescope, or various kinds of devices. And then on top of that, now we've added electronics on top of these complex lenses, where we have the software doing a lot of the magnification and manipulation of the images. We've talked about a lot of that in the last 2 or 3 weeks. We talked about how the photography astronomy is all black and white, and how we manipulate color on top of there with RGB and LRGB and so on. So, but it's basically black and white. So today we're going to talk about the easiest way to find yourself in the sky. First of all, you have to have a location in the sky, and that is celestial North Pole. That's also where the North Polaris, North Star, Polaris, is located very close to that. So most people use Polaris for a pretty rough estimation of exactly where north is in the sky. So then you have degrees down and sideways, right accession and declination. On the Earth we call that latitude and longitude. So they're circles, starting with the great circle, 2 small circles. Usually the great circle is at the equator. Okay, then you might have another great circle at the meridian. And then as you go from there, these circles get smaller and smaller from 0 to 90 degrees or 0 to minus 90 degrees at the South Pole. So, if you want to learn and start at the bottom with the naked eye, the first thing you have to do is find Polaris, the North Star. Now it's just like manipulating around a city in your car. You got to have landmarks, you might have to have a map and so on to get around. So you've got to have some way to find your way along the sky. So you start with the constellations that are called circumpolar, which means they will be there year-round. So it's easy year-round to find your way and to learn your way around the sky. They go around Polaris, and then at certain degrees it stops off, and you'll only have that constellation there maybe for 3 months out of a year, or 6 months out of a year. But you will not see it for 6 months when it's down under the equator or down under where it's going to be at negative collimation. So we're talking about positive collimation, which is 90 degrees above you. That's called the zenith. So at the zenith then, that's 90 degrees, and that's where you'll find the start of everything. So in this case, we're going to talk about, so Lisa draws a circle with a dot in the middle of it high up. That's your sky. So we usually think about the sky as a circle or sphere. In actuality, mathematically, none of celestial things are hardly ever in a circle or sphere. They are usually, because of physics and math, they are elliptical. But most people draw them as circles. So we're going to work with circles. And the globes that you buy are all circles or spheres. This does lead us into a different kind of mathematics. In geometry, it leads us into what we call spherical geometry, because now a line is no longer the same size. A line on a circle with 2 pi r radius, for example, is longer in a sphere because now it's become what we call a great circle. So draw a line across the equator. Yeah, and put north for North Pole and south for South Pole. Okay, so that's a great circle. In other words, it's long in that line across there because it's elliptical, 1 and 2. It becomes longer. Therefore, once you move above the ground with ground maps, terrestrial telescopy, we call it, telescopic navigation. Let's say you move a foot above the ground, you're into another world. You're into the world of that the sailors were in. Okay, Columbus, all the people who came before us and were sailors, because when you're on the ocean, you don't have trees, you don't have skytop buildings and so on. So it's a little bit different when you're out in the middle of the water. You may have waves, you may have currents and clouds, but you don't have obstructions. Therefore, their world and their navigation and their mapping is somewhat different. So the first thing you have to realize is when you're doing marine navigation and celestial, celestial means of the sky, going to the moon, going to Mars, you're into celestial navigation and you're into spherical mathematics, spherical geometry. Okay, now draw a line from North Pole to South Pole. Now most of us will know that as you go up from the equator, which is 0, you're going up to plus 10, plus 20, we'll call it about north now, up to North Pole, which is plus 90. If you go down to the South Pole, it's going to be minus 90. However, those of us and most of the academics in the last 100 years have really come from above the equator, the northern hemisphere. Therefore, we don't talk a lot about the South Pole and some of the constellations in the south. Okay, so now you think about that as the Earth. Okay, now stand somewhere where you might in Texas on there. Okay, so now what you've got is, and we've gone over that before with the circle of units, where we've gone over the sine, the cosine, and we did a little bit on the tangent. But now the tangent starts coming in. So draw a line from that guy up 90 degrees to the surface. Up, yeah, there. And then draw a line tangent 90 degrees. That's a little hard to comprehend. this way. Okay. So now we've got the geometry and trigonometry of right angles and other kind of angles and so on. So, and that's the Earth. Now draw another circle on the other side and do more or less, no, wait, I got to backtrack on my thinking there. Okay, that is the celestial sphere. Now, you have to realize too that most of our learning in the past century was two-dimensional. Now we're working in a three-dimensional world, and the young people have to learn 3 dimensions because we're working with 3D printing, 3 dimensions. We're working with MRI. We're working with different kinds of 3D dimensional activities. Therefore, it's a little hard to learn because it's a little bit more complicated than what we had when I was in high school. So now draw a point right in the middle and draw a circle around there. Okay, that is a circle. Draw another circle, a bigger one. Okay, and another one. Okay, that would be our latitude. So the easy for those who have trouble with those words, latitude is like a ladder. You climb the ladder up to the North Pole. So longitude goes around the other way. So the little circle there, the first one, is a circumpolar part. So that's what we're going to work on today. The circumpolar constellations. There are 88 constellations. Easy way to remember that, if you're into music, there's 88 keys on a piano. So there's 88 constellations, and we're only going to work on a few of them. So draw another circle, a bigger one in the middle. Okay. So now, put a dot for it in the middle. That's the celestial North Pole. That is Polaris, the North Star, polar star. So everything is going to go around there. So get your little map. I gave you a map there. So the title of this presentation is The Royalty of the Sky. So astronomy's gone on for over 2,000 years. Therefore, those who are into it, generally speaking, if you get a PhD in it, more than likely you have to get a degree. In your degree program, you have to be accomplished in one other language. In the old days, that was French, okay, German for science, French for diplomacy, and so on. So, and those are the 2 languages that were used a lot. But when we go before the European age, what we call Romance languages and so on, we had the Arab, the Arabic people involved, we had the Chinese involved. So there are all kinds of names up there and writings that are a little bit hard for us U.S. citizens to understand. So the first one we're going to talk about is Cephus. So there's a lot of Greek in there too, with all these names. Some of them are Greek names, and they have Greek mythology behind them, so there's stories behind them. So Cephus is the king. He's the king of the sky and the king of the royalty. Okay, so he leads the pack. So Cephus looks like a box, and he's got a little pyramid on top of him. So a lot of kids all the way back to 1920s in school had to learn about Cephus. That was kind of mandatory. So anyway, look on your map and see where they have Cephus and draw him there. Okay, so Cephus, as always, will have a queen. So the queen is Cassioopia. So Cephus kind of looks like a king. He's got a box, and he's got the crown on his head. Actually, Cassiopeia looks to me kind of like a crown too, at least the crowns that we wear now for our pageants and so on. Or she looks like a W, so draw Cassiopeia the same as it is on the sky map, where she is on the sky map. Okay, draw her a little bit further apart. Down a little bit more.
She's
I'll tell you why later on. Okay, so as I said now, when it goes around the sky, you'll see these going around and around. So every day they're going to go more or less around a whole circle. So the other two now they're not part of the royalty, but they're an important part of this finder process. In your scope, you'll have what we call a finder scope. So these are the things you're going to look for in the finder scope before you turn on your real telescope. So the first one you have to be aware of is the constellation Ursa Minor. That's a little bear. But most of us refer to part of it, which is an asterism in the little bear, Ursa Minor, and that's a Little Dipper. So look at your map again. What you have to do is make sure the Polaris is in the right place with the Little Dipper. This is very important now. The last star in the handled Little Dipper is Polaris. You see it? And this is what you do have to digest a little bit and get this into your head, because we're going to talk about the Little Dipper and the Big Dipper. So, Polaris is part of the Little Dipper. It's the last star in the handle of the Little Dipper. You got it? Yes? No? Okay, did you draw it?
no. What do you want me to draw?
Okay. It's going to be something like this. The last star in the Little Dipper. I can't read it there. Here, draw it like so, like this. Okay, now put some dots down there. No, here, 1, 2, 3. No, in line. That's the handle of the dipper. 1, 2. Okay, now, let's do it this way. Now, draw, there's a little bucket there. Okay. This is not easy stuff, by the way, but you have to learn it if you're going to get into astronomy or into flying airplanes or be a sailor in a boat. This is mandatory. So now comes the Big Dipper. So the Big Dipper, we're taking some what they call poetic license here. So the Big Dipper, I want up here, okay? So the Big Dipper is just like the Little Dipper is, except it's big. Okay, wait. This part of it has to point here. Go ahead. Good. We'll straighten this out in a minute. That might get a little bit easier. So the Big Dipper, if you take 5 finger widths of the dipper, 1, 2, 3, 4, 5, it helps you lead you to a certain area. So what we're talking about now, these are directional, okay, or positional astronomy. It gives you a position in the sky, okay. So You will use it later on when we get to Messier object, which we'll talk about in another session, of the Big Dipper alone and the Little Dipper alone, how you might be using those separate. But right now we're talking about the royalty of the sky, that whole circumpolar part. So next comes the daughter, Andromata. Andromata. That's the daughter of Cassioopia and Cephus. She's a little bit further down. Okay, she might not be entirely within that circumpolar part, but she's part of the royalty sky. Okay. Now what we're using here, I don't know if you can you zoom on at that? These are called sky charts. This particular one is made by the American Astronomical Society, yes it is. Comes out every month. Comes out in English and Spanish. And it usually comes out with various aids or tips. It may have 1, 2, 3, 4, and then an arrow. So sometimes they teach you in astronomy to follow from here to there with your fingers. You can measure with your fingers, your fist, in the sky and so on. So they'll say it's 4 degrees so far from there. And you can use this, which we'll go over some other time, how to tell the degrees in the skies with your hand and so on. So that comes out every month, and you can find it online in Spanish and in English. Okay, now turn the chart around so we see the black side. These are 3D printed. These come from a university that has done a lot of research into how to teach to blind students astronomy. So what they've got is the constellations, and they're in type Braille type. They're called tactile learning, where you learn with your fingertips and so on. So you can print out the constellations, and we have done that. They also have numbers on, so you can test somebody. Okay, they can feel for number 4 or look at it if they're visually impaired, and then they can tell you what it is. Okay, so anyway, I have them set up here more or less as we are on the other chart and so on. So, can you tell what they are or not? Okay, where's Cassioopia? Okay, so again, a blind student now, or visually impaired, could be feeling it with their fingers. And Cephus. Okay, and then the one in the middle is what?
The Little Dipper.
Okay, and then we've got one I didn't talk about. This happens to be what, you know?
Is this Pegasus?
Okay, that is the asterism,
Is
the
it?
Big Dipper,
No.
okay, but inside of Ursa Major. So if you get into an astronomy program and bring up what they call the cultural part of it, cultures in the past have drawn a bear there. So that's why it's called Ursa Major. So they'll have a bear rather than a stick. We go with stick figures, and the stick figures are part in a program, if you look them up, started by a gentleman by the name of Reyes, R-E-Y-E-S. And he wrote a whole book on it, so that's become standard too. So we've got one up here we didn't go over, and that's called Draco. And Draco fills up pretty much the rest of the sky. Draco is the dragon, okay? And he fills up the rest of the sky where the queen and the queen are not, and so on. There's one other one there, which we won't go over because you're going to have enough problems just trying to figure out how these guys go, is Cameloparus, which is the camel, and so on. So basically then, take all these and shift them around. No, they gotta go like so. Okay, if you're looking at the sky, more or less that's what happens at night. Okay, if you're looking in north, most of us do astronomy look east because things are going to come up. But if you're looking at the polar part of the sky, the circumpolar part, then they're going to go around. So if you go out at 8 o'clock, they'll be where they were. Then you go out at 12 o'clock, they will have moved like that. So move them one more time. Same way. This is where you have to start learning in this generation what we call spatial relationships. If you take Cassioopia or the queen, when you go looking for them, at one point of the night, they will be here. And the next point of the night, they'll be upside down. So even if you have it in your mind, you have to be able to start transfer this in your head. So in astronomy, this gives us another problem. As a general rule, once you bring through light through a lens, it does certain things to it. It does certain things to the light. It bends it, and it bends it in a different way. It'll bend red different than green, different than blue. So that means you have to buy a better lens, which is going to be more expensive because you don't want them bent different. You want them all bent the same, which means different mathematics because they're different. So you throw a lens in, and what happens with any kind of lens as a general rule is up becomes down, left becomes right. So now when you start looking through a telescope, everything is upside down, or right versus left. This caused a problem with early moon research. So when they sell moon maps like this, they'll actually sell two of them. One for the people who want it one way, and one for the people who want it the other way. And I have both of them. So it depends on how you want to learn it, or your teacher, and so on. And then you in your mind, because the moon is not going to be straight up and down, it's actually going to be tipped just like the Earth is. So you have to start doing all this in your mental imaging process. We looked out now, those of us who have moved forward with astronomy,